If you're trying to make a move into software development, one of the questions that you might find yourself asking or someone asking you at some point is, do you want to work on the front end, the back end, mobile, DevOps, embedded systems, IoT type things, kernels? So many options. So let's talk about them and let's make sure that you have what you need to answer that question. So I'm going to pull up Draw.io. So if you're unfamiliar with that, let me swap to the appropriate scene. So Draw.io is just a diagramming tool. I'm going to create a blank diagram and we're just going to draw a little because I think that'll help paint the picture. So let's talk about people. So this is you. This is your mom. This is your dad. This is your brother. This is your sister. This is someone using a service on the internet. We'll start there and we'll work towards embedded systems and kernel type stuff in a moment. They are going to make a request to a website. So let's say I'm just going to type text. Let's say they go to facebook.com. Great. I don't need to worry about the formatting. So a couple different things are going to happen. There's a lot going on here, and we'll talk about that at some point, maybe in this video. But once the request gets to facebook.com, this is going to hit what we would call a front end. So this front end is what you visually see. So if you go to facebook.com, you see your feed, you see your friends, you can interact with it. The front end is what users interact with. It's unique to their computer, and it communicates with something referred to lovingly as the backend. So we're going to add that here. This is the backend. This is how, in a very simplified scenario, most modern websites function. There have been, a long time ago, these used to be one and the same. There have been efforts recently for some companies to make them one and the same again, where the back end and the front end are serving the same thing. By serving, I mean returning stuff to the user. So when you go to facebook.com, the stuff that is returned to you is what's served by the front end. That is the front end experience. In fact, I said the word experience. Let's put some words next to this that help from a cloud, like a word cloud perspective. So if you hear UI, user experience, JavaScript, CSS, HTML, these are the things that really comprise the front end experience and maybe compromise depending on how well you write your JavaScript. On the back end, these are the things that you're going to hear that are like words such as server, server side, database. You can make a case that this is different, and it usually is, and we'll get to that in a second too. Languages like Java, Ruby, Python, Go. I'm not going to put Rust. Rust is one too, but Rust is nice enough that you could use it for front end technically too. And I don't really want to get bogged down with technicalities. Go, Python, yeah, those type of things. And worth mentioning, JavaScript. And I'm going to call that out specifically because out of all these languages that are listed right here, JavaScript is listed in both. That's important. We'll get to that. So I mentioned databases. So the backend talks to something called a database. Most backends for large companies like Facebook talk to many databases or they access data from different databases. If you don't know what a database is, then the short and sweet is that it is something that stores user data. Or maybe not user data, but data. So if I want to, maybe embellishing on this example a little bit, if I go to facebook.com and I post a status update, here's how that works. So I type in facebook.com and I hit enter. I get the front end. The front end comes all the way back to my browser. Now from my browser, I send a request to the back end. And this right here is me posting a status update. Or maybe it's uploading a new photo. Or, anything that Facebook lets you do. So I post this status update. That goes to the backend. The backend does some stuff like validating it. Was it really Brad who posted the status update, or was it someone impersonating him? Do we need to validate the status update and make sure it's not too long? Twitter for a long time, I'm still calling it that. Twitter for a long time only had a 140 character limit. So if you tried to type in something that was 156 characters, the backend would say, nope, you can't do that. That's too long. So if everything's good, then it will store the data in the database or do whatever it needs to do with it. If it's bad, for whatever reason, the backend will send a response back to my browser and say, hey, something went wrong. The front end catches that and then shows me an error message, because the way that the backend and my computer talk together does not make sense to most users. So the front end sets in place and essentially translates, it puts a user experience on communicating with the backend service. Okay, so we've talked a lot about this. I'm going to mention one more thing here before we add a little bit more to this diagram. JavaScript is mentioned in both of these. JavaScript's an interesting language. I was going to say a fantastic language. In a lot of ways it is. It's done so much for web development. JavaScript is used when you build a front end, you'll write HTML. HTML is the hypertext markup language. It helps you mark up your content. So it helps provide information to the browser about your content. This is a picture. This is an article from a journalistic source. This is a quote. This is a table of data, that type of stuff. CSS stands for cascading style sheets. CSS makes things pretty. Or not, if you're not good with it. It could turn out very ugly. But the idea behind CSS is that HTML content on its own was really bland and hard to look at. So CSS can help make things pretty with colors. It can help organize content. It can help position content. And it can do a lot. JavaScript is it's the cherry on the icing on the cake. And JavaScript lets you do so much. It adds interactivity to your front end. So JavaScript is what communicates with the backend for you. It's what makes it so when you click a button, something happens. It's what makes it so when you, I was going to say hover over an image, if that image were to change. Technically, I think you can do that in CSS at this point. But the point being that most of the complex logic on the front end comes from the JavaScript layer because there's no spot for it for the HTML layer or in the CSS layer. Okay. I mentioned that because JavaScript can also be used on the back end. And one of the things I recommend to new devs when they're learning programming for the first time is that if you don't know what language you want to use, JavaScript is an excellent choice. I have a video, I'm going to link it somewhere. And it's a programming tier list for new devs who are getting into software development. Spoiler alert, JavaScript is my number one pick. I have a lot of people who pull up that video, presumably don't watch the whole thing because they don't understand why I chose JavaScript as a number one pick, and then leave comments saying, I can't believe you picked JavaScript. Yeah, it's because if you only have the time to learn one language, or if you're learning a language and you can only pick one for now, JavaScript is going to help you find employability on the front end and on the back end, which is fantastic. With that in mind, there's this concept known as a full stack developer. This person does all of this. Usually they're not great. I shouldn't say they're not great. Usually they're not an expert at any of it, but are instead a generalist at all of these things. That's not always the case, but often it is. So let's add another thing into the equation. This is a giant phone. I'm going to shrink it down. Maybe not like that. Yep, like that. And then we'll move it. We'll move it right here. There is also this idea that a person might not be using a computer, a conventional computer, I should say. They might be using a mobile phone. So if someone's using a mobile phone, the front end is essentially replaced. And the front end is replaced with a mobile app. So you have these. If you're watching this video, you're probably watching it on a mobile app. You might be watching in your web browser, in which case you're using the YouTube front end to talk to the YouTube backend, which has my videos stored in their YouTube database. This is a gross simplification of how things work at YouTube. The systems are a little bit more complicated than that, but the idea here is still the same. So you have a mobile app and it replaces the front end. So we're going to change this from front end to front end web. And by web, I mean something that is ran in your browser. So in the mobile space, not all mobile apps talk to a backend, but a lot of them do. So Facebook talks to a backend because, and here's how you can identify if it talks to a backend. If you can see content from other users, it talks to a backend. If it's making network requests, if it doesn't work with Wi-Fi and your data turned off, it's using a backend. It might be kind of hard to understand that at first, but basically a backend is a server that aggregates data and interactions from these things called clients. So a client would be the front-end web client. The mobile app would be a mobile client. And then it might pull, so if I post a status update, it might send me content back to the front end or the mobile app that say, hey, thanks for the status update. Here are the top 5 statuses your friends posted recently, or something like that. Some apps don't have a backend. I built an OCR app, so an app that uses your camera to scan barcodes. And it doesn't use a backend. I'm sorry, not barcodes. I built one that scans barcodes too, but an OCR app is one that scans, like you can take a picture of text and then it generates an actual text representation of the text in the image. Doesn't use a backend, all runs on your phone. That's something that can totally be done with mobile apps. That being said, most businesses that use mobile apps talk to a backend and they collect data and store it in a database. So this is kind of the same idea. On mobile, if we wanted to post a status update, we would, pull up our phone, post a status update. It would go to the backend. The backend would store it in the database. The database would say, hey, you're good. I've got that. It's stored safely. The backend would then say, hey, I successfully stored the thing you wanted me to. It would say that back to the mobile app. And then the mobile app would show me something. It would show me a green little bubble that pops up and says, you're good. Your status update's been posted. Okay, let's put some more words to mobile. So when you think about mobile, we are talking about mobile phones. We're talking about cell phones. We're talking about iPads and tablets. What else? We're talking about, let's add some programming languages to this. Specifically, we're talking about Android and iOS. There used to be other options. There's not really other options anymore. And on Android, you're writing either Kotlin or Java. And on iOS, you're writing either Swift or Objective-C. I'm weird. I love Objective-C. I don't recommend people learn Objective-C. It is a very strange language. I like it a lot, but it would not be what I would recommend. In fact, if you wanted to learn mobile, I would recommend learning Kotlin for Android and Swift for iOS. And if you're unfamiliar with iOS, it's iPhone's operating system. They have a operating system called iPadOS and watchOS. These all use Swift and Objective-C. Just like Android has, Android Wear, you're going to write Kotlin and Java for Android Wear, just like you would Android phones. So, if you, for some reason, really just want to be a watch developer and develop apps for the Apple Watch, you're going to use Swift and Objective-C just like you would for an iPhone, which is great because those skills can carry over. Okay. So that puts some more context to that. Let's add a couple more things. So I mentioned IoT and I mentioned embedded systems. Our Facebook metaphor really starts to break down here. So the idea of an embedded system is an embedded system would be a really, really small device. So maybe your refrigerator. Maybe your refrigerator. There's a fair chance that if you have a very fancy refrigerator, it runs on Android because that seems to be more and more popular. But your refrigerator, your washing machine, what other small devices do we have around here? I have an electric hand warmer. That might be an IoT device. There's a small chip in there. There's something programmed. I wish I had more examples. If you wanted to do something with an Arduino, so an Arduino, Arduino, I can spell it, I promise. You know, an Arduino or a BeagleBone. These are small microcontrollers that are built to do a small set of interactions. So they're pretty cheap. They're little tiny microcomputers, and they're very cheap for what you're getting. But the idea is that you would, buy some sensors maybe, or buy a motor or something and connect it to your Arduino or your BeagleBone. And then you would write some code to activate that motor or read from those sensors or put it all together. And when you read from those sensors, activate that motor. Or maybe, for example, one of the projects that I did with an Arduino was I built I bought some motion sensors and an LED strip light. And when the Arduino detects motion, it lights up the strip light. You stick that under your bed, and now when you wake up in the middle of the night, you have lights at the side of your bed so you don't trip over all the clothes that you've been meaning to put in the laundry, but you keep forgetting about, and your wife keeps reminding you about. Is that just a me problem? Maybe. Okay. So these would be your embedded systems, or your IoT, Internet of Things. Another example, it's really hard to say because Android's become so invasive into IoT devices, but there's a chance that you have a home camera or maybe a lock on your door that can be controlled via your phone, or maybe your garage door can be controlled via your phone. These would be examples of IoT devices. In a business case, here's another example. Maybe you work in the agricultural industry and you have sensors that are planted all over a 100-acre farm that a company owns. Or somebody owns, and they pay that company for these sensors. Maybe those sensors collect data about the soil, composition and the hydration of the soil, and then send that data back to a server somewhere. Maybe it's a server in a data center, kind of like our Facebook example, or maybe it's a small server that sits on the farm and just shows the farmer information about how dry the soil is. That would be another example of like an IoT type situation. The other thing I mentioned was kernel development. If you're looking for a job in development, this is what I would recommend. And in fact, if we really want to get particular, I would recommend this. I would not recommend mobile. And I'll talk more about why in just a second. Kernel development would be really, really low-level development on bigger computers. So not IoT type devices, but like Linux, like the operating system, or Windows, or things of that nature. Things that they're very performance intensive. You write very raw code using a language like C or C++, maybe Zig. It's a newer language. I really like it. I wouldn't necessarily recommend learning it if it's the first thing you're learning, especially if you're looking for employment, because I don't think there are a ton of Zig opportunities at the moment, but maybe one day. And so that would be kernel type development. I don't recommend learning it because if you think about all the websites we have, there's a lot of these. If you think about all the operating systems we have or all the kernels that we have, there's not that many of them, especially non-open source, so things that you would likely be paid to work on. If you think about mobile apps, there's a good number of those. Probably more websites than mobile apps. Don't quote me on that. And then databases. We can add a little bit to this too. What I've noticed as a trend in the industry is that a lot of people who are working with databases are developers. So people who work on the front end or the back end, full stack, mobile, that type of stuff. This used to not be the case, and we used to have a role called database admin. We still do. I'm sorry if you're a database admin and I've offended you with that statement. They still exist. They're just a little less common now than they used to be. I remember that companies were hiring for DBAs like crazy. I don't see that as much anymore. Maybe that's my own perspective. Maybe it's not. So there were DBAs, which stands for Database Admin. DBAs work with tools like MySQL, PostgreSQL, MongoDB, DynamoDB. That's an AWS offering. What else? That's probably a good gist. Depending on the company, you might end up working with something like Redis too. Redis also might not be a database admin thing. Kind of depends on the company. But yeah, these are more or less ways to store data. And that's essentially what a database developer or a database admin would do. So this is covering software development in particular. There's data science, there's machine learning, there's AI training, there's AI engineering, all sorts of things. There's a lot of options, and we haven't covered all of those, honestly, because I'm not the best person to cover those. I don't do data science. I don't really do much in the machine learning space. It's slightly changing, but not that much. So I'm not the best person to talk about that. So if you're interested in software engineering from a web, backend, mobile, database, IoT, and slightly kernel, notice we didn't even add it here because that's how much I recommend choosing it. Yeah, this is what I would recommend. Oh, the one I was forgetting. So there's a role that has popped up a while back. It's called DevOps. There's also a role called DevSecOps. There's also a role called Ops. These aren't necessarily the same thing, and I'm sorry, but I am going to lump them into the same bucket. I am going to remove Ops from this list and lump them into the same bucket. So DevOps, what DevOps is developer operations. So what does operations mean? Operations mean taking the code from your machine and figuring out how to operationalize that, which usually means getting that into a service that runs it, like Amazon Web Services, AWS, Google Cloud, GCP, or Microsoft Azure, which is Microsoft's cloud compute platform, and more, Microsoft's cloud platform. But it doesn't have to be those. It could be other providers too. So you'll work with the teams to take code from their machine and help figure out how to integrate that into something called a continuous integration pipeline, or CI pipeline. And then there's also a CD pipeline, which is continuous deployments. So you'll work with CI/CD pipelines to integrate code continuously and deploy code continuously. And then if we want to get particular on the SecOps, Sec stands for security. So this is developer security operations. I'm not the best person to talk about this. This is not an area of my expertise, but it's an area that I'm seeing more and more traction in, especially in terms of hiring and people just being brought onto teams. So it's similar to DevOps, but with a security-focused mindset. Unfortunately, that's about all I can say about that. As for the actual day-to-day, I don't know what the day-to-day looks like for them. Okay, so circling back one more time, here's a list of roles. We have a front-end engineer that focuses on this stuff. You know what? I'm going to add one more thing because this is more popular. React. And I'm going to add Svelte because it's my favorite. And Vue because it's still popular. And still good. I'm not trying to knock Vue. These are front-end frameworks. So these are written in JavaScript, and they help you write JavaScript, CSS, and HTML. They're very, very popular. So that's front-end engineering. Back-end engineering would be server-side type stuff, focusing more on business logic and validations and communicating from server to server. So a backend may talk to another backend. It may talk to a database. It may talk to other things. There are these ideas of queues that a backend could talk to. That's Queue, like when you wait in line for something, that would be a queue. That type of stuff. So that would be backend engineering. Mobile app would be, mobile engineering, and you would usually you pick Android or iOS. Usually you don't do both. I did leave out one of my favorite pieces of technology here called Flutter, and also React Native gets a shout out too, because why not? So Flutter and React Native let you write iOS and Android apps from the same code base. So you don't have to learn Kotlin and Swift. You just learn Flutter. And Flutter has a language called Dart that it uses. So it's more or less, you can use them interchangeably in this case. And then React Native uses React, which was mentioned up here, and JavaScript to build mobile apps. And again, it has the same benefit as Flutter, which is one code base for both iOS and Android, which is really nice. I love Flutter. I build stuff in Flutter all the time. I've worked employed as a Flutter developer. I've also worked employed as an Android and iOS developer on separate occasions. Actually, my very first job was doing Android and iOS. And then, a long time ago now, 7, 8 years ago, I was doing Android development specifically. They're still around. I don't let the 7 or 8 years ago scare you. Still around, still a great choice. And then we mentioned database administrators, DBAs, working with data, working with databases, making another thing that database admins sometimes might do is what we would call like business analyst type work or even business intelligence type work. And this would be taking data from a database and furnishing it so that people who work at the company can get reports, they can get actionable dashboards, so they can see like, do we have less users using the app today than we did yesterday, that type of stuff. And then we talked about DevSecOps and CI and CD a little bit. So again, DevOps is operationalizing the developer process. So taking this stuff and figuring out how to deploy it. Sorry, I should probably select mobile as well. All of this really. And don't let this scare you. This doesn't mean you have to know how to build websites or front-end web apps. This doesn't mean you have to know how to build backends. This is about taking these things that other people build. Sometimes you might build them. And figuring out how to get those running in an environment that is serving real user traffic and is working and scaling like you would expect it to. And then over here, we talked about IoT. I don't have any fancy diagrams for IoT. Think of them as really, really small computers. So if you wanted to, make your own watch, for example, IoT development might be a good place to start. Also, Android development might be a good place to start because, like I said, Android is becoming more and more popular for IoT-related things. And then I also mentioned kernel development. I don't know why I mentioned it. I really just... And I know why I mentioned it, because it's a possibility. And it's also a very lucrative possibility. I feel like kernel engineers get paid a good chunk of money. But are there a lot of jobs? I don't think so. I'd love to be proven wrong on that. So if you are watching this video and you're not a junior dev and you know that I'm wrong, comment in the comments below and let me know. Provide some sources. I'd love to be wrong and hopefully help people find those jobs. I think that about covers it. I did mention that we would circle back to this at some point. When a user types Facebook into their browser, there is so much that actually goes on behind the scenes. So this goes to something called a DNS server, which is a domain name service server. Maybe it's domain name server. Not sure why I threw the extra S in there. And what this does is that it translates this to an IP address. So an IP address would be something like 101.102.88.462. Random IP address. If that's yours, I'm sorry if I just sent your IP address out there. The whole point being that like your computer doesn't know what Facebook.com is. Facebook.com is for us. Your computer understands IP addresses. Those are Internet Protocol address, I believe. I haven't had to explain that acronym in a very long time. So I might be incorrect on what it stands for, but it's an IP address. And what that means is that DNS server says, oh, they want to go to Facebook. That's here. It's like when you type into Google Maps, you type in something and it's not exactly correct, and then you hit enter and Google Maps corrects it for you. That's what a DNS server does, but it helps you find websites instead of real life places. So that DNS request comes through, and then it tells your computer, this is where you want to go to find Facebook.com. Your computer makes a request there. Facebook probably has a ton of infrastructure right here. So this could be things like load balancers. This could be things like an API gateway, all sorts of things that are way beyond the scope of this video. There are people that set this up. Sometimes that falls into the DevOps role. Sometimes it falls into like an infrastructure engineer role. Sometimes a platform engineer, potentially an architect, depending on what the work is. There's stuff that exists there too. We could go on and on and on about all the possibilities here for opportunities in employment in this flow. But again, these are the highlights, the ones that I would recommend people look at. So if you want to build websites, the things people see, like what we have on the screen, or like this, or what else we got? This pretty stuff with colors and different fonts and making things easy to access and accessible and easy to read, things like that, and interactive, like the search right here. So if I search for, let's search for Svelte, maybe you can see that this is interactive. It's returning stuff. This data from this probably comes from a backend. It doesn't necessarily have to, but it almost certainly does. So the interactivity would be typing in this and then sending a request to the backend with this information, and then the backend would show me everything that is, or it would send back everything that's relevant for my search, and then the front end would display it. So that's, that would be front end engineering. The backend engineering would be fetching this data from the database, formatting it so it's appropriate, making sure that it's not sending me data that I shouldn't see, Maybe it's sensitive data for certain individuals or something like that, and then sending that back to either the front end or the mobile app. The mobile app is exactly what it sounds like, mobile engineering. You build a mobile app. That mobile app may or may not talk to a backend. In a lot of cases, it probably will. And it kind of works like the front end, but instead of it being in your browser, it's on your phone. Database, again, we talked about this. This is about structuring data, optimizing it so it's easy to read, easy to write. And by easy, I mean quick to read or quick to write. Most of the time, people aren't reading or writing that database to that database, but instead the backend is. So you're optimizing for the backend to quickly retrieve that data as quickly as possible. And then I mentioned, IoT one more time. This would be the example being someone who built devices with moisture sensors that are in a 100-acre farm field that send data back to the farmer about how dry the soil is. And then DevSecOps and DevOps, again, that's operationalizing all of this. I know that's kind of vague. I don't have a better way to phrase that. Hopefully this has been helpful. So if you are trying to figure out what role you want to find and explore, again, you don't have to be stuck in them. I've done mobile, I've done front end, I currently do backend development for a company. I've kind of done it all. And some people choose one and they specialize in that one for their entire career. Some people bounce around a lot like me in terms of what they're doing. Both are fine, but you got to start somewhere. So hopefully this has helped you decide where you would like to start. If you found this video helpful, please let me know. I want to make more content for people who are just getting into the field, but I'm not sure what you need to know. It's been a long time since I was in that spot. So I'm helping a friend move into the software engineering field, and hopefully that'll give me inspiration for more things like this. But in the meantime, let me know what you want to know, and I'll do what I can to help out. Thanks. Have a great day.